So in this video, I'm going to go over how to apply trigonometric substitution, which is one of the common ways that you're going to be asked on how to take an integral. So in this case, we have x squared plus 16 over x to the fourth power. And one thing I do want to familiarize yourself is with this table that I have on here. We have a minus x squared. If you see this, you apply this substitution, x equals a sine theta, so that its derivative is this, a cosine theta, and this holds true. So what I do want you to keep in mind is that trig sub is basically just a case-by-case basis. So we have three potential cases, which are these right here. So for step one, what we're going to do is we're going to apply the appropriate trigonometric substitution. So I do want you to make a note of this. Trig sub has three different cases. Get used to the table down below and apply the proper case according to the trig sub table. So in this case, we have x squared plus 16. So which case would it be? Would it be a squared minus x squared minus a squared, or a squared plus x squared? Well, since we have a plus sign right here in between the x squared and the 16, we can safely assume that it'd be this one, the middle one. It would be a squared plus x squared. So x is equal to a tan theta, and dx is the derivative of tangent, which is secant squared. So since we see a squared plus x squared, we apply x is equal to a tangent theta. So now the next step for trig sub is we're going to identify the variables of integration. I think this part's very important because after this, it's just plug and chug, but you do need to know how to identify these. So there's actually a lot. So right here, just follow along carefully. So the first thing we know is we know our a squared is equal to 16. We know our a is the square root of a squared, so it's equal to 4. Thus, our x, we know x is equal to a times tangent theta. So what's a? A is 4. So x is equal to 4 tan theta, which means our x squared, because right here we have x squared, so we're actually going to want to substitute in whatever x squared is and not leave it as x squared, because we want this in terms of theta. So x squared would be 16 tangent squared theta. And x to the fourth is equal to x squared, which is equal to 16 times tan theta squared. So in essence, x to the fourth power is equal to 16 squared is 256, tangent squared is tangent to the fourth power. So that's our x to the fourth. And our dx, the derivative, would be a times secant theta, which is squared, and our a is 4, so it's 4 secant squared theta. So now that we have all the variables of integration, we're going to plug them in. But just make sure you take a variable for every last term in the integral. So I took one for x squared, for x to the fourth, for dx, and then a squared and a and x, those you always have to take them. And then whatever you're left with in your integral, make sure you take a variable for each term, because when we substitute everything back in, we only want things in theta. We do not want any x's. What we're going to do is we're going to plug in the variables into the integration, the variables of integration into the formula. So keep in mind that our original formula is x squared plus 16 over x to the fourth power times dx. And keep in mind all the variables of integration that we came up with were these right here. A squared, a, and now we're going to plug them in. So we're going to plug in for x squared, for x to the fourth, and for dx. So x squared plus 16, we can leave the plus 16 since that's technically our a squared. X squared, we're going to plug in 16 tangent theta squared, plus the 16 that's already there. For dx, we're going to plug in 4 secant squared theta times d theta. And for x to the fourth power, we're going to plug in our 256 tangent to the fourth power. So now we're going to integrate this function with respect to theta, now that we have everything in terms of theta. So the first thing we're going to do is we're going to try to simplify all the constants. So we know we can separate the square root. We can factor out a 16, and we're left with tangent squared plus 1. And that's just a matter of factoring out. and 4 secant squared theta times d theta divided by 256 tangent to the 4th power. So what we're going to do is we're going to simplify the constant. So we know the square root of 4 is 16 times this 4 over here is the square root of 16 is 4 times this 4 makes it 16 divided by 256. So that's all our constants. So tangent squared plus 1 times secant squared theta times d theta divided by tangent to the 4th power. So now what we're going to do is we're going to apply Pythagorean identity. So we know that secant squared is equal to tangent theta squared plus 1. So that's a Pythagorean identity that we can use right here. Keep in mind that inside the square root we have tangent squared theta plus 1, so we can actually substitute secant squared theta for this right here. So that's what we're going to go ahead and do. So we can factor out the 16 over 256, which reduces to 1 over 16, and we're left with secant squared theta inside the square root times secant squared theta times d theta divided by tangent to the 4th power. And in doing so, I know that the secant squared theta and the radical will cancel each other out, and I'm left with just secant times secant squared theta divided by d theta times tangent to the 4th power. So keep in mind, all I did right here was there's a radical, the square root and the square will cancel each other out. So that's why I did that. And when I simplify this, I get secant cubed times d theta divided by tangent to the 4th power. So now what I'm going to do is I'm going to actually convert sine and cosines by applying the trig reciprocals. So this step right here is just a matter of trigonometry, not even calculus. So the trig identities that I need to know, the trig reciprocals, I know that tangent theta is equal to sine over cosine, and I know that 1 over tangent is equal to cosine theta over sine theta, which is equal to cotangent. And I know that secant theta is equal to 1 over cosine theta. So I put green brackets around the ones that we're actually going to substitute. So now what I'm going to do is I'm going to substitute in everything that all the trig reciprocals. So first keep in mind that our original function was secant cubed over tan to the 4th power times d theta, and this is equal to 1 over 16. Secant cubed, secant is 1 over cosine, so secant cubed would be 1 over cosine cubed. Tangent to the 4th power would be cosine to the 4th power divided by sine to the 4th power times d theta. So now what I'm going to do is I'm going to simplify this just a little bit. So I have cosine to the 4th divided by cosine to the 3rd times 1 over sine to the 4th power. And I know that d theta, and I know I can simplify by canceling out most of those cosines, so I'm left with cosine theta divided by sine to the 4th power. So keep in mind, all I did right there was cancel out the cosine, because the exponent of 4 minus exponent of 3 gives us an exponent of 1 times d theta. So now I'm going to apply u substitution. And of course, the best term to use for u substitution is whichever one has the higher power. So in this case, it's sine. So u is equal to sine to the 4th power. So our du is equal to cosine theta times d theta. And our d theta is equal to du divided by cosine theta. And I'm going to put brackets around the u and the d theta because those are the ones we're going to end up substituting back into the integral. So we're going to substitute u and d theta back into the integral that we have. So now we're going to integrate this with respect to u. So we have our constant of 1 over 16 times the integral of cosine theta over u to the 4th power, because we're substituting in u for sine theta. And then for d theta, we're going to substitute du divided by cosine theta. And we see that those cosines will cancel each other out. And we're left with 1 over 16 times du over u to the 4th power, which is equal to 1 over 16 times u to the negative 4th power times du. So now we can integrate this applying the power rule. So in doing so, we integrate this, we get u to the negative 3rd divided by negative 3. We raise by 1 power and we divide by the same power. So that's the power rule. Plus c. And we can rewrite this as negative 1 over 48 times 1 over u to the third power plus c. And negative 1 over 48, our u, we're going to plug it back in, is sine cubed theta plus c. Thus, we get negative 1 over 48 sine cubed. We can rewrite it 1 over sine is the equivalent of cosecant cubed plus c. So now you might be tempted to say that we're done, but we're actually not. See, our final answer has to have terms of x, because that's what our original integral was given to us in terms of x. So that theta that we have there, we have to get it in terms of x. So how do we do that? So now what we're going to do is we're actually going to solve the cosine secant theta to get it in terms of x. So how do we do that? Well, we do have to apply the triangle rules. So familiarize yourself, of course. I'm pretty sure you've seen this. If you're in Cal 2, you've probably seen this before. SOHCAHTOA. So keep in mind, what was our x equal to? Our x was equal to a times tangent theta. So we can actually do with this, because we can solve this for theta. So we can do that. So we know x over a is equal to tan theta. And we know tangent theta from SOHCAHTOA. We know theta, tangent theta is equal to opposite over adjacent. And we know that from tan theta. From geometry, we know that. So furthermore, we know the opposite is equal to x over a. What's our a? Our a was 4. Recall. So now we're going to identify the opposite, adjacent, and hypotenuse. So our opposite, of course, is equal to x. Our adjacent is equal to 4. So our hypotenuse must be equal to, we know from Pythagoras, we know the hypotenuse is equal to the opposite squared plus the adjacent squared. So thus our hypotenuse is equal to x squared plus the adjacent, which would be 4 squared. So our hypotenuse is equal to x squared plus 16. So now we have the hypotenuse, the adjacent, and the opposite. So now let's solve for cosecant theta. So in step 5b, we're going to identify cosecant theta. So we know sine theta is equal to opposite over hypotenuse. And we know cosecant theta is equal to 1 over sine theta. So the reciprocal would be equal to cosecant theta. So the hypotenuse over the opposite. So the hypotenuse was x squared plus 16 and the opposite was x. So now cosecant theta is equal to x squared plus 16 over x. So now we're going to substitute cosecant theta into the integral to finish this problem out. So we have negative 1 over 48 times cosecant cubed plus c. And yeah, it's very tempting to say you finished right at theta, but you're actually not done. You do have to apply trigonometry, and then you're finished. So we can simplify this to negative 1 over 48 times x squared over 16 divided by x, and this is being cubed, plus c. Furthermore, we can simplify this negative 1 over 48 x squared plus 16 raised to the 3/2 divided by x cubed, and all I did was distribute the 3 power plus c, and we can say that that's our final answer because it's in terms of x. So yeah, this problem is very long. Trig subs are very long problems, but I think they're very straightforward. This problem was probably a little bit more trivial than a normal trig sub problem, but the idea is that first you identify your variables of integration. Then you plug them back into the trig sub, you integrate with respect to theta. Once you do get an integral with respect to theta, which I think the integral for this one was a little bit trivial, but once you do get the integral, which is the important part, you get theta in terms of x, as I did right here on this last page. Anyways, thank you for watching. So in this example, we're given 1 over x squared divided by x squared minus 16. So keep a note that the trig sub has 3 different cases as stated in the table down below in the bottom left hand corner. So we have x squared minus 16. So step 1, we're going to apply the proper trig sub. So which one do you think would be the best one to apply? As it turns out, we have form of x squared minus 16, which is the form of x squared minus a squared. So we're going to apply that substitution right there. So x squared minus a squared. So since we see x squared minus a squared, we can apply that x is equal to a times secant theta. And we're going to use this information to do step 2, in which we identify the variables of integration. So for step 2, what do we have? We have x squared, a squared dx. So let's identify these. So we know that our a squared, x squared minus 16, x squared minus a squared must be equal to 16. Thus our a is equal to 4. And our x is equal to a times secant theta. And a is equal to 4, so which is equal to 4 times secant theta. And our x squared is equal to 4 secant theta squared, which is equal to 16 secant squared. And our dx, the derivative of secant, is the constant of 4 times secant theta times tangent theta times d theta. So now that we have the variables of integration, let's plug them in. So now what we're going to do in step 3 is we're going to plug these variables of integration into the formula. So the original formula that was given to us was the integral of 1 over x squared times x squared minus 16 inside a radical times dx. So again, the variables of integration that we had were a is equal to 4, a squared is equal to 16, x is equal to 4 secant theta, x squared is equal to that, and dx is equal to 4 times secant theta times tangent theta times d theta. So what we're going to simply do is we're going to plug these into the formula. So we know our dx is 4 times secant theta times tangent theta times d theta. So that's us plugging in for dx. For x squared, we can plug in 16 secant theta squared. And for the radical, we're going to plug in x squared again. So 16 secant squared theta minus 16. So now let's integrate this in terms of theta. Step 4, we're going to integrate this with respect to theta now that we've plugged everything in. So our plugged in formula is 4 over 16 times secant theta times secant squared theta plus tangent theta times d theta times secant 16 secant squared minus 16. So that's everything plugged in. All I did was just move the constants to the front. Furthermore, what I'm going to do is I'm going to reduce 4 over 16 to 1 over 4. I'm left with 1 over secant theta. As I reduce secant theta, right here where my mouse is, secant theta divided by secant squared theta is equal to 1 over secant times tangent theta times d theta divided by what's inside the radical, which is 16 secant squared theta minus 16. So now what I'm going to go ahead and do is I'm going to simplify this a step further, and I know that I can simplify by factoring out a 16 from the radical, and I'm left with secant squared theta minus 1. So 1 over 4 times tangent theta divided by secant theta times d theta divided by 4. Because I can factor out what the 16, I can take the square root of it, which is 4 times secant squared theta minus 1. But where do I go from here? Well, we have to know the Pythagorean identities, and we know that we can apply secant squared theta minus 1. We're going to apply Pythagorean identity. And we know that secant squared theta minus 1 is equal to tangent squared theta. Thus, we can substitute tangent squared theta, which is a lot easier to work with than secant squared theta. So 1 over 16 tangent divided by secant theta times d theta. And then we're going to substitute the tangent theta inside where secant squared theta minus 1 is. So now we're left with tangent squared theta. In doing so, now this problem just became simpler to deal with that radical. So d theta divided by tangent theta, because the square and the radical will always cancel each other out as long as it's the square root. So now what I can do is I can cancel out those thetas, those tangent thetas, and I'm left with 1 over 16 times d theta divided by secant theta. And recall the Pythagorean identity of 1 over secant theta is equal to cosine theta times d theta. So when I integrate this, I get 1 over 16, and the integral of cosine theta is sine theta, of course, plus c. But now that we have it in terms of theta, we need this to be in terms of x. So now we're going to go ahead and solve this sine theta in terms of x. So to do this, we have to apply our SOHCAHTOA that you should be familiar with. So I'm not going to go too much into detail what SOHCAHTOA means. So we know sine theta is equal to the opposite over the adjacent, O over H. And we're going to identify the opposite adjacent and the hypotenuse of which variable is which. So we know that x is equal to a sine theta, a secant theta. And we know that x over a is equal to secant theta, which is equal to 1 over cosine theta. And we know that 1 over cosine, when we reciprocate this, we get the hypotenuse over the adjacent. Why? Because we know cosine theta is equal to adjacent over hypotenuse. So when we reciprocate it, it's the opposite. So it's hypotenuse over adjacent. So that's where that's coming from. Cosine theta is adjacent over hypotenuse, but when you reciprocate it, you're also reciprocating the hypotenuse over adjacent. So that's where that's coming from. So we know this is equal to x over a, and we know our a is 4, as we already identified what that was. So now we know we're going to identify hypotenuse is equal to x, the adjacent is equal to 4. So now we have these so we can solve for the opposite. So again, we know from Pythagoras that hypotenuse is equal to the adjacent squared plus the opposite squared. But when we solve for the opposite, we know, doing algebra, we know that the hypotenuse squared minus the adjacent squared is equal to the opposite. Thus, we know the opposite is equal to x squared minus 4 squared because the hypotenuse is x, so we're just going to square it minus the adjacent 4 squared. And when we evaluate this, we get the opposite to be x squared minus 16. So that's our opposite term. So now, let's identify sine theta. So again, we know sine theta is equal to the opposite over the hypotenuse. So what we can do with this bit of information is we can just plug in what we have. So we know the opposite is equal to x squared minus 16. We know the hypotenuse is equal to x. So this right here is equal to sine theta. So we can substitute this in terms of x where sine theta was in the integral. So now we're going to substitute it into the integral. So now our integral will be in terms of x. So we are with 1 over 16 sine theta plus c. So now we're going to substitute where sine theta is 1 over 16, the square root of x squared minus 16 divided by x plus c. And that's the answer to this problem. I hope this was helpful. If it was, thank you for watching. Feel free to like, share, subscribe, comment, leave feedback. And I have a whole playlist on calculus, Cal 1, 2, 3, etc. And I'm going to have a lot more playlists in the future for all kinds of classes. Anyways, thank you for watching.